My name is Lee Payne, and I serve as the AmeriCorps Communications Associate in Boone, North Carolina's Office of Appalachian Voices, which is a regional environmental nonprofit. As part of my service with AmeriCorps, I'll be collecting feedback on today's discussion through a short 4-question survey. The survey will be distributed at the end of the webinar, but if you need to leave early today, I'll also be sending out an email link. It'll take just a minute to fill out, and I really appreciate hearing from all of you. Now let's get started with today's discussion. We're going to be taking a look at energy efficiency and how you can reduce your monthly bills and your carbon footprint by becoming more energy efficient. The average American household uses and pays for about 20% more energy than they need to because of such things as old appliances that no longer work properly and poorly insulated attics that let heat escape in the winter. By identifying and reducing these sources of energy loss, you can make a noticeable financial and environmental impact. I'm so glad that all of you are here for this discussion. Joining us this afternoon are Jennifer Alldredge, the Education Program Manager for the Alliance to Save Energy, a national coalition advocating for energy efficiency as a solution to global energy needs. Also joining us is Renner, owner and project manager of Conservation Pros, an Asheville-based business that specializes in providing energy efficiency and weatherization solutions for homeowners and businesses in Western North Carolina. And finally, Rory McIlmoil, the Energy Policy Director right here at Appalachian Voices. The main topics that we'll be discussing today concern what energy efficiency is and why it's important, what individuals can do to become more energy efficient, and what programs are available to help folks make these energy efficient home improvements more affordable. We'll be starting today with an introduction to the topic, which will be led by Jennifer Alldredge. Next, we'll hear from Renner, who will provide information about things that you can do to become more energy efficient. And finally, Rory McIlmoil, will discuss programs that are available to help pay for these home improvements. And he'll also introduce the work of the energy savings team here at Appalachian Voices. There will also be a chance to ask questions after each of the panelists has finished speaking. On the right side of your screen in the GoToWebinar panel, you'll find a drop-down box labeled questions. If you'll type your question here, I'll pose the questions to the panelists at the end of each session. We're going to begin our discussion now with Jennifer Alldredge. She will start us off with a discussion of what energy efficiency is, what impacts it has on individuals and the environment, and some of the benefits that can be gained through energy efficiency. Jennifer is the Education Program Manager for the Alliance to Save Energy, and she works primarily on the Tennessee Valley Authority's Green School Program. Thanks so much for joining us, Jennifer.
My name is Jennifer Alldredge, and I work for the Alliance to Save Energy, which is a nonprofit organization based out of Washington, D.C., though I happen to live in Knoxville, Tennessee, and work primarily in the Southeast. The Alliance to Save Energy promotes energy efficiency worldwide to achieve a healthier economy, a cleaner environment, and energy security. Through the course of my presentation, I'll be addressing all three of these elements. To get the conversation started, I wanted to begin with two key terms that we often use interchangeably: energy efficiency and energy conservation. They are related, but have their own specific definition. Energy conservation is generally described as really behavioral choices, such as deciding to turn off the lights when leaving a room. Energy efficiency is really more about the type of equipment or technology that's used, such as a decision to purchase a CFL or LED light instead of an incandescent light. Both energy efficiency and energy conservation will reduce your utility bill, and both will result in saving energy. They also overlap somewhat because even the most energy efficient light bulb needs to be turned off when it's not needed, or it becomes what we at the Alliance call energy hogs, wasting energy and also wasting your money. Another great example of energy efficiency in action is actually the refrigerator. Now, modern refrigerators are really the poster child for energy efficiency, as over time they have gone from an average use of around 1,800 kilowatt hours per year back in 1972 to less than 500 kilowatt hours per year now, with a significant increase in capacity. So the energy efficiency of refrigerators has increased. Energy conservation is how we use the refrigerators, by choosing to keep them full, especially in the freezer section, and by keeping the door closed as you're pondering what it is that you'd like to remove. Now, here in the Southeast, we use a lot of electricity, more so than actually in the rest of the country. While this chart is a little bit dated as it's back from 2008, it shows that homes in the Southeast use 30% more electricity than the rest of the United States. And there are a couple of reasons why we Southerners like our electricity so much: cost, weather, and education. Historically, electricity in the Southeast has been relatively inexpensive. My apologies, this chart is a little bit difficult to see, but because energy has been relatively inexpensive, of course it attracts greater use. We also live in a climate with weather extremes, requiring air conditioning in the summertime and heat in the winter to keep us comfortable. And with lower electricity prices, our heat has been historically electric. Also, opportunities for education have not always been available, as it isn't mandated the way it is in certain other states, most notably California. And this is another reason why I'm very grateful for Appalachian Voices in providing this tremendous service to everybody today and throughout the course of the year. The other issue that we Southeasterners need to keep in mind are the sources of our electricity. This data hasn't changed very much over the last 5 or 10 years. And as you can see, we've maintained a heavy reliance on fossil fuels, most notably coal. If anyone on the line is from West Virginia, reliance on fossil fuels compares to Kentucky, with a 95% of their electricity from coal-fired power plants. If you're on the line from Virginia, you can look more at the Mississippi. Sadly, I wasn't able to find any charts that had specific states, but this really did illustrate the southeastern region. Now, energy efficiency isn't just about monitoring the type of fuel that's used to create electricity, and this all is just simply background information, because the choices that we all make do matter. Here in Knoxville, I have the opportunity to work on the Knoxville Extreme Energy Makeover Program, which we call KEAM. This program gives professional home weatherization to qualifying Knoxville City residents, provided they attend an education class, which I happen to provide. In the class, I often get a chance to speak with the residents who struggle with their utility bills. And I'm surprised that the questions are not just about energy conservation and efficiency, but also about environmental impact. While many people are motivated to become more concerned about their energy consumption because of financial costs, there's also a large percentage who are equally concerned about environmental issues and how to make more sustainable choices. So with that in mind, I have a little bit of information about this from that perspective. So from a global perspective, the United States uses a lot of energy. This is why energy efficiency is really critical at this time in human history. How we create energy that we use does make a difference. Now, as you can see here, the generation of electricity is the primary source of U.S. carbon emissions, even more so than transportation is across the board. This is due to our heavy reliance on fossil fuels, specifically coal, and it takes a great deal of coal to literally keep the lights on. This picture shows the amount of coal it takes to keep one 60-watt light bulb on for 12 hours per day for 1 year. So to keep the lights on, it does literally take a mountain of coal. Burning fossil fuels also contributes to other issues, such as particulate matter in our atmosphere, contributing to pollution and health concerns such as asthma. I won't go into the extraction methods for fossil fuels, but of course, as we all know, this is another concern that's very not environmentally based. Unfortunately, fossil fuels are also extremely inefficient sources of electricity. Coal-fired power plants are only 30% efficient. So to break it down, for every 100 railroad cars of coal that you see, all of which are burned to generate electricity, only 30 of them actually produce electricity. Even more electricity is lost in transmission from power lines to the end user. Current technology can't change the efficiency of the grid, which is why we have to consider alternatives. We all see that our climate is changing. Although currently it is snowing out here, that's just weather, not climate. And the way we generate electricity does make a difference. I don't want to just point fingers at the fossil fuel industry because all sources of electricity have environmental impacts. Nuclear energy, while much cleaner in terms of carbon emissions, carries significant risks in terms of waste material. And the prime element needed for nuclear reactors is uranium-235, which is a non-renewable element. While renewable energy sources such as solar panels are significantly better for our environment, placement of large arrays does impact local wildlife, as do wind turbines. And our current manufacturing processes need some improvements to make renewable energy truly environmentally friendly. While it will be decades before these critical issues are resolved, which is why energy efficiency is so critically important. Energy efficiency has no negative environmental impact. It is simply about making choices to reduce your energy consumption, either through the energy you don't use through conservation choices, or through the choices that you make to take advantage of some of the newer technological options, such as CFLs or LED lighting. Energy efficiency also happens right here in the United States, which directly relates to energy security. In today's somewhat unstable global environment, our reliance on products produced outside of the United States is of great concern for many people, particularly when it comes to the energy industry. When it comes to your behavioral choices, those happen where you live, work, and play. The choice to purchase energy-efficient technology also happens right here at home. The final piece of the energy efficiency puzzle has to do, of course, with money. Once again, using lighting as an example, because we've all changed the light bulb, and it's something that's very common and easy to use as an example. And I talk to a lot of people about their lighting choices. Every time I speak to somebody about purchasing incandescent light bulbs, they usually argue that all the other lighting is just simply too expensive. The reality is, it's the reverse. All other considerations aside, purchasing inexpensively winds up costing us a tremendous amount more. Again, to use lighting, just to carry the same theme through, if you take your incandescent, CFL, and LED light bulbs, all three will generate light. And lighting tests show that a 60-watt incandescent, a 13-watt CFL, and a 9-watt LED all generate more or less the same amount of light. If anything, the LED is brighter due to the technology of the light bulb. Now, incandescent light bulbs are very inexpensive to purchase. You can spend probably about 50 cents, maybe even a little bit less if you want to purchase this type of light bulb. However, you have to consider their lifespan, which is about 800 hours, meaning that if you have a light on for 8 hours per day for 300 days, you'll need 3 light bulbs over the course of a year. The math just adds up. A drawback of the incandescent light bulb is also a heat factor. These light bulbs average about 350 degrees. So if you ever had an easy bake oven when you were growing up, you know they get pretty toasty. And placement of the lighting matters. You definitely don't want to place one near any thermostat. So if you need 3 light bulbs, you're spending $1.50 per year for your lighting. If your cost of electricity is 10 cents per kilowatt hour, which is much easier math and actually fairly common throughout the Southeast, you're spending a total of $15.90 every year for that single light bulb. Now, this may not seem like a lot, but it is if you compare it to your option. CFL light bulbs use the same technology as all fluorescent lighting, and while some take a few minutes to come up to full light, they ultimately do the same lighting job as incandescent. However, they will last considerably longer. One light bulb will last between 3,000 and 5,000 hours, meaning you don't have to purchase them as often. You can buy these light bulbs for, at most at this time, about $1.50. So while the initial cost appears considerably more than the 50-cent incandescent, because CFLs last so much longer, you're actually spending the exact same amount of money. Less energy is also lost as heat, as the CFLs don't get quite as hot. With the difference of wattage, the incandescent being 60 watts and the CFL being only 13, the amount you are spending to to keep the CFL light bulb on is considerably less. So you get right down to it, energy efficiency is really a mindset. It's thinking about energy use in terms of productivity rather than as waste or losing something. The reality is, if you change something as simple as lighting from incandescent to CFL light bulbs, you're actually saving a total of $11.28 per light bulb. That's sound economics and the best way to truly improve your energy efficiency. And of course, don't forget, you still have to turn them off because the most energy efficient light bulb is still going to be an energy hog if we don't choose energy conservation. Now, looking toward the future, LED lighting is the newest lighting, and I have to carry this entire lighting theme through, and it's more energy efficient. In lighting, you can always tell what is more efficient because wasted energy shows up as heat. The hotter the light, the more energy is being lost as heat rather than being emitted as light. LED lights stay much cooler to the touch, even hours after being lit. LEDs also last between 30,000 and 50,000 hours, making them a very wise investment, especially for the workplace, because their long lifespan means less labor costs in replacing them. The key for the home is the cost of the light bulb, which continues to go down as the technology becomes more common. I always recommend keeping a close eye on LED pricing, because currently you can spend anywhere from $2 for a non-dimmable basic light bulb, if that's an LED, to $8 or $9 for something that's a little bit more fancy for the home. The examples I've used is about lighting, but actually this really applies across the board when it comes to energy efficiency. You can see that energy efficiency is in fact worth the perceived investment. Energy efficient products use less energy, provide a comfortable environment, as well as ultimately reducing costs. I appreciate your time, and I will now turn this back over to Lee and see if there are any questions.
Thank you so much, Jennifer. We do have a question from the audience. Before I read through that, just a reminder, if any of the rest of you have questions, on the right-hand side of your screen, if you'll just drop down the tab that says questions and type any questions that you have there. And in future presentations, feel free to submit those questions at any point. You don't have to wait till the end of the presentation to submit. So our first question, it says, in the charts comparing the Southeast to the US, you mentioned the 30% greater electricity use in the Southeast compared to the US in residential. But what contributes to the astronomically higher electricity use in the industrial sector in the Southeast?
That's a great question. Well, within the industry itself, and I know I was primarily focusing here on residential, but of course industry uses a tremendous amount of electricity, and there again, if you're looking in terms of lower electrical costs, and you're talking about your heating and your air conditioning systems, which I'm sure will be addressed at a later point during this presentation, a lot of industry will choose to use those as electrical as well. So there are other factors within it, but that's primarily it. We also have a lot of industry here in the Southeast, so that contributes to that overall large percentage of electrical consumption in that particular sector.
Wonderful, thank you. Are there any other questions? I'll give just a second to see if anything comes in. Yeah, well, if you have additional questions for Jennifer, we can continue to return to this topic in the future sections of questions as well. So continue to submit them in. And we'll switch now over to Marcus. So Marcus Renner is the owner and project manager of Conservation Pros, an Asheville-based business that specializes in providing energy efficiency and weatherization solutions to homeowners and businesses in Western North Carolina. He has a master's degree in sustainable building and more than 20 years of experience working in the industry. Thank you so much for joining us, Marcus. What can you tell us about making our homes more energy efficient?
Well, what we're going to do is basically look at the home as a building envelope. So let's get started here. We call this in my industry building science, basically the science of how our homes operate and interact with us and the environment around them. Getting into the efficiency of our homes, as mentioned before, we want to go with efficiency first. If we save it, we don't have to make it. And in a running theme you may hear through my presentation is that when you look at efficiency as an investment, as there are other investment strategies that are available to us as consumers, efficiency is actually the best investment with some of the best returns that you can make. And another big point I want to make is that we're not just looking at a financial savings here. When we make our homes more efficient, when we stop airflow coming in from outside, we actually do a number of other things. We increase the indoor air quality of the home many times. If we have combustion equipment like a furnace, we can actually make the home safer by addressing the efficiency of the home. By stopping air movement, we stop bringing moisture into the home so we can increase the durability. And we can also, of course, increase the comfort. And I tell my customers, put a price on comfort. It's hard to do. It's a valuable commodity. Now, this is the pyramid of conservation. This is a great beginning point and a great way to understand kind of the bigger picture as well. What we see is that down at the bottom are simple things that a homeowner can do, or even just a resident of a home. Knowing how your house works, looking at turning things off. Then lighting, and as you go up, what we see on the left is as you go up the pyramid, things get harder to do and they get more costly. And I'm not going to go into each thing here, but I do want to point out that the fourth thing from the bottom is air sealing, which we'll see from my presentation is a really big issue in our homes. I want you to notice the second to last thing near the top is actually windows. Windows, it turns out, are not the problem in our home. As occupants, we perceive them as a problem because we feel the wind blow through them, but as a whole, they're not responsible for the majority of our energy losses. We'll talk about that a little later. Now, we talked about investments. This is a chart, once again, a little dated, showing the stock market here on the right in the 90s when it was really hot. Gave you a 14% return on your investment. Down at the bottom are all the different energy, or many of the different energy efficiency upgrades you could do to a home. So let's just look at wrapping your water heater with a layer of insulation, an additional layer. That will pay itself off and give you a return of about 27, 26%. So you can see here on the right again that most of these features from an efficiency standpoint will give you a better return, will get your money back in your pocket sooner than our traditional methods of investing. So the money argument alone is a no-brainer. Now, let's look at our homes. What are the problems? Air leakage, number one. The EPA has found that air moving through our home is responsible for about 40% of our energy loss. So 40% of the money you spend to heat is going out. In the winter, heat rises, escapes out of the top of the home, and then brings in cold air from the bottom of the home. So for instance, if you have a crawl space, that cold air is actually coming through your crawl space. And the number one way that that air is driven in and out of our home is the stack effect. If your windows are closed, there is stratification happening in your house, and our air is trying to move through our home. So that's sort of the basic idea with air leakage. Now, when we look here at this chart, we see that the main areas of our home that are responsible for air leakage are the building envelope, the floor, walls, and ceiling, and then the ductwork, where we put our conditioned air. Many times this is outside of our home, either in our crawl space or our attic. Notice the windows are only responsible for about 10% of the losses. So when we look at where we want to address energy efficiency, we know that it's with air leakage first. And when we look at dealing with air leakage, we know we want to deal with ductwork and the floor, walls, ceiling, and floor. We can address all these things later, but the overall efficiency of those and the overall payback are longer, so we want to hit the low-hanging fruit first. Do notice the fireplace here. An open hearth fireplace, by the way, many times is negatively efficient. It actually causes more heat loss than you gain, so it's something to be aware of. Another EPA picture here just showing where our heat goes through air leakage. Now we see the red and orange arrows rising out of the attic, out of that ceiling, and then we draw in cold air from the bottom. If you air condition, this is reversed, and we are actually, cold air sinks, and we let the cold air escape out of the bottom, and we draw in hot attic air. Common air leakage point. This is some homework. I'm not sure you were aware you had homework, but if you can go under your home to where your bathtub is and go in either in the basement or crawl space if you have one, you'll probably see something like this. A very large hole for a very small pipe. So what happened here, nobody really did anything wrong when it came to the construction of this home. There was just nobody that was responsible for the air barrier or the air leakage of the building. So we have a bathtub put in, a nice large hole is left open, and we all know that, for instance, if this was a crawl space, there's not the most healthy air down there. So we tend to draw that air into our home. Many people often ask, why does my bathtub cool down so quickly? Well, this is the reason. You're drawing cold air around it. Another one, this is a picture from an attic, and what this shows is basically if you look at your ceiling and you see a light, in the attic you'll see something like this. This is an electrical box with the wire going to it. And what this person has done is pulled the insulation back from this electrical box. And first you can see all the holes, and this is a little bit of an older one, but even newer ones are like this. And you see all this dirt. This is filter. This is acting as a filter. This insulation is a filter. So what we want to do is air seal this and stop that air moving and thereby the dirt. By the way, many times the color of the dust can tell a building scientist what's going on in the home. This looks like they may have had a fireplace in there, or they burned a lot of incense or candles, because it's a sooty type of dirt in the insulation there. Now, how do we solve that? Stopping air leaks, we can save 15 to 20% on our energy bill, depending on the home. Here we just use some foam out of a handheld foam gun or your typical Great Stuff can and seal that up. Another picture shows where we have wires and wall top plates. We want to seal that up. So essentially we go and make a map of your ceiling and then find your interior wall top plates, your wires, and your lights, and seal that up, and do that below as well. Getting on to ducts. Ducts are just as important as the building envelope because they have our conditioned air, our expensive air that we pay money for, and we want to seal them up with mastic. Tapes don't work. The EPA has done a number of studies across the nation and found that 20 to 30% of your conditioned air is lost through leaky ducts and through tapes that have failed. So we really want this paste-like substance on this. This is something any homeowner can do as long as they understand it, or you can also get a professional company to do it as well. Here is an interesting example. This is a ceiling duct, so this ductwork is in the attic, and what has happened, they've put in the duct boot, and they've put a nice hole in the sheetrock, and as you can see, there's about a ½ inch gap around that. Now, because of the Venturi effect, when air is blown through this duct, you actually have a negative pressure around it. Now, you wonder, like, wow, that's a pretty sloppy job. Well, we have to keep in mind that America is built by the lowest bidder, and as consumers, we've made that choice to have a cheaper product, and then that's essentially what we're living in. And then we have companies like mine that get to come in and fix all the problems when the home's too costly to live in or not comfortable. Here's what that looks like through an infrared camera. This duct is actually heating the ceiling underneath the insulation, so it's heating in the attic and wasting quite a lot of heat into an area that it shouldn't be going. Something we see probably about 15 to 20% of the homes that we go into is just broken ductwork. We use lower cost materials like this flex duct, which in general is okay, but over time it ages, or you have different people going into the crawl space and damaging things. And we see all sorts of broken ductwork, and people find that they can't condition part of their home, or their heating system is just operating for long periods of time without cooling or heating, and it may be a problem like this, which is quite common. Now we get to insulation. So we've talked quite a lot about air sealing, which is the most important thing, and then we come to insulation. And people ask, what's the #1 thing you should do? And it's always air seal first and then add insulation. Adding insulation in a floor system or in an attic is, without air sealing, you'll get about 60% of the effectiveness out of that insulation. Insulation doesn't stop the air movement, and air movement is pretty much the #1 loss of energy. So once you've air sealed, let's look at insulation. There are many options out there. Depends where you're installing it and what your needs are that are really going to make the call for you. But really want to focus on the ceilings and floor first, then followed by the walls. And that's in general because really our heat goes through the ceilings and the floors more than it does the walls through the stack effect. This is improperly installed insulation. So this actually is a cabin with a vaulted ceiling, and you can see that there's the joists are really insulating more than the insulation. We can have problems with this Around the eaves, you can see that it's still cold and frozen. That can cause ice damming and a lot of water damage. This is a great time of year to go around looking at people's insulation levels. You can just see the frost or snow melting on the roofs. Whenever we have a plane change in our attic as well, for instance, here's a vaulted ceiling, they're very popular. We basically can have a situation where areas aren't insulated. So you can see the bright, hot attic. This is a summer day. This whole wall that is exposed to the attic is not insulated. And this once again comes down to just the lowest bidder was responsible for the building envelope here. And the insulation company did not insulate this wall. Once again, very common out there in the real world. On the attic side, this is what it looks like. The insulation just starts falling away. It's not secured properly. And here's the correct way to solve that, is to put some kind of rigid barrier on that insulation so that it can both stay in place and perform properly. And you can see, when we start changing the building envelope from a simple square or rectangle, and when we start adding these wall changes and ceiling changes, you're really depending on the insulator to understand how the building envelope works and to understand where both the thermal envelope and the air leakage points need to be protected. And here's a common thing for an existing home. You can go in and add additional insulation. We like cellulose insulation. It's a recycled product. It's one of the better insulators out there, and it's a pleasure to work with. However, other insulation products are available that do a fine job as well. Now, that was the building envelope. There's a whole lot of other things we can talk about with the building envelope, but let's get on to some other uses. When we look at where we use energy, most of it's used for conditioning, heating and cooling. The next large amount we use is for water heating and water use, so we want to address that. Switching to Energy Star appliances, you can do the math and realize that it pays to get rid of your old appliances and get new appliances right away. Don't wait for them to break down. To replace them is costing you money in the long run. Water use as well at the faucets can be easily changed with the aerators. These cost about $1 to $2. This has one of the best paybacks in energy efficiency. It'll pay itself off in about a week, and then that money's going into your pocket. And of course, shower heads as well. And we save twice with low flow fixtures, because not only are we saving on the water cost, but also we're saving on the cost of heating that water. Mainly with the appliances, look for the Energy Star label. Generally, they're going to be about 15 to 20% more efficient than the standard appliance that's not Energy Star rated. And you can get a lot more efficient than that. And usually it's worth the money. And usually what we found is that Energy Star rated appliances are built better as well, so they actually have a better track record than a regular appliance. In water heating, there are a lot of options out there. I tell people look for the Energy Guide first to make sure it has an Energy Star logo on it. One of the most efficient water heating options now is the new heat pump water heater, much like a heat pump for your home. A very unique device. It's been out for a little while now, so they're worked out the kinks. Another option are the tankless, but you do need gas for that. You do not want an electric tankless because they will not save you money. And as mentioned before, lighting, we have to understand that the incandescent bulb is 146 years old this year. So I think Thomas Edison and the others that worked on that are probably ready for a change as well. So it pays to get rid of your incandescents right away and replace them. If you do have compact fluorescents, wait for those to burn out before you replace those with LEDs. Also, maintenance. Once you notice, this is the bottom of a refrigerator. This is a coil. This is supposed to have airflow. This is not working properly. Here is a clothes dryer vent. This was a 30-foot long run, which is too long, but this is also the fifth cause of house fires. So make sure you read those manuals and maintain the equipment. I recently learned that my dishwasher has a filter on it on the drain end, which will make it more efficient. And finally, get an energy audit. It's just when you go to the mechanic with your car, they don't look out the window and tell you what's wrong with it. They take it into the shop and plug it up and test drive it and do all things. So you can get an energy audit and have a blower door test done and basically get a mechanic of sorts to look at your home just like they look at your car. And with that, I thank you.
Wonderful. Thank you so much, Marcus. That's Fantastic presentation. And we already have a great question from the audience. And again, if any of the rest of you have questions, just go to the drop-down menu on the right-hand side of your screen. So the first question is, many of your recommendations apply largely to homeowners, but as the owner of a condominium, what kind of energy efficiency steps can I do to improve my condo's efficiency?
That's a great question. Generally, condos are standalone as far as the energy. You're paying your own bill for your own unit, and generally they only share a wall. Now I'm talking, I guess, about 1 or 2 story units that have their own attic and own foundation. You can still address the foundation and attic just like you would a normal home. If your condo is in a multi-story building where you have units below and above, oftentimes you can, it comes to air sealing, you can look at your interior walls, your interior finishes that are adjacent to another unit, and seal those areas up just with simple caulk. And you can also look at your appliances. So it just depends on the individual unit, but many times they can be addressed just like a home, and the only difference is you have adjoining walls that you normally wouldn't deal with first anyway.
Excellent, thank you. Yeah, we have another question, which I'll paraphrase slightly. The first part is, are there flammability concerns with the spray foam sealants and light fixtures? And also, would you recommend an energy audit before doing air sealing?
Flammability, so we use, for air sealing, we use caulk, but predominantly we use a foam. It comes out of a handheld foam gun. You can buy a similar one at the hardware store. The ones we use are fire rated, so they're designed to address heat from fire. So not necessarily a fire concern. And also you have to understand that we're plugging up holes, so inevitably we're making the house more fireproof because we're stopping the air pathways which actually supply fresh air for a fire, for combustion. So it becomes a little more fireproof, although scientifically that may not be proven yet, but we are plugging holes. As far as light fixtures, the light fixtures can be sealed except if they're a recessed light. And recessed lights are basically, the ones that are flat on the ceiling or flush with the ceiling. Those have to be addressed in a different way. And this is a great question because that whole safety part in the beginning, this is another safety concern for weatherization or energy efficiency. We don't want to seal, cover up these lights and then they can catch fire. This happened in Australia. They had a number of home fires from this. So we do address those in a different way with a fireproof airtight cover that goes on them. Or you can just switch those out to LED lights now. They have a really nice kit that makes an air seal and also is an LED light for those. And then I would suggest an energy audit before air sealing. We have gone to a couple of homes that don't need air sealing, i.e. they're too tight or they're just tight enough. That we do want our buildings to breathe. However, we want to control where they breathe from. We don't want them breathing from the attic or crawl space. We want them to use clean air or fresh air, not dirty air. So yeah, I would suggest an energy audit because we've often gone in and individuals have thought they needed one thing and it turns out that didn't necessarily need that or it wasn't top on their priority list, and it actually saved them quite a bit of money. So it's a very inexpensive way to get a roadmap for the energy future of your building.
We have one last question. Thank you, Marcus. What would you suggest for apartment renters to improve the efficiency of their units?
That's a great question. First, look at so your heating and cooling devices, you can't necessarily make changes to that without the approval of the owner. The building envelope, the insulation and whatnot, you can't necessarily make changes to that without the approval of the owner. What you can do is seal the interior. So if you go into a room and you look at what walls you share with another unit or share with the outdoors, just caulk any seams that you see that appear to be leaky. So, generally the interior finish, our sheetrock, is the air barrier. So where it meets window trim, where the wall meets the floor, or the floor meets the ceiling, just make sure there's some kind of caulk bead. But really, for a renter, what you can look at is, your other loads, your water, going with low flow. Those are things that you can take out as you go. When I used to rent, and compact fluorescent bulbs came out, I replaced all of my bulbs and then I took them when I left. Your appliances as well, especially the things you plug in, what we call your plug loads, are another great way to save energy there. And I know there are a lot of resources online for for renters what they can do. And possibly if you do have access to your attic or your crawl space, you can do some simple air sealing. Of course, I'd recommend talking to the owner of the building before moving forward with that.
Great. Wonderful. Thanks so much, Marcus. We have a couple other questions, but we need to get on to our final speaker. If there's any questions that we don't have time to address during the webinar, we'll try to get back to each of you with answers to your questions. So thank you so much, Marcus. And now I'd like to introduce Rory McIlmoil, who is the Energy Policy Director at Appalachian Voices. Rory oversees our energy savings team and is working very hard to increase the energy efficiency here in Appalachia by making necessary home improvements more affordable. Thanks so much for joining us, Rory. What can you tell us about programs that can help make these changes affordable?
Yeah, as mentioned, I'm the Energy Policy Director for Appalachian Voices. For the past few years, we've run a program that we've called the Energy Savings for Appalachia campaign. The purpose, this was sort of one of our new solutions-based efforts with the goal of reducing energy costs for Appalachian residents throughout Central Appalachia, thereby alleviating the high levels of poverty in those areas, and at the same time promoting local economic development. And I'll talk a little bit more about that in a moment. And our main approach is to promote specific energy efficiency finance programs to rural electric utilities, such as rural electric cooperatives, to develop on-bill energy efficiency finance programs that are accessible to residents who typically don't have great credit scores or can't access other financing or pay for energy efficiency improvements themselves. And associated with that, we do a lot of community outreach and education, energy efficiency workshops, and in many cases partner with local energy efficiency providers such as Marcus, one of our best partners, to join in those presentations and offer local residents a lot more information about ways that they can improve their home energy efficiency. And as I mentioned, one of our goals is to alleviate poverty mainly in the Central Appalachian region, and what you're looking at here is the average poverty rate by electric utility service territory throughout the Southeast. The national average is 16%, and as you can see, most of the region is either at or above that level. And so given the high or low efficiency of energy use in the region combined with the poverty levels, you can see that there is a significant problem that energy efficiency can help address. In the Southeast, this is a map that Appalachian Voices created. Another kind of indicator of the problem is that folks on average spend more of their income on utility bills. This shows just electric bills. The national average, according to the federal government, is that folks throughout the United States spend approximately 2.8% of their gross annual income on all energy bills, including gas for heating, electricity, and looking at just electricity bills, you can see most of the region is at or above that level, particularly in predominantly rural states such as Tennessee, North Carolina, and other areas. So energy efficiency, as evidenced by the existence of companies such as Marcus's, such as Conservation Pros, can have a significant economic impact. And because of that level of potential, that level of need for savings, there's a potential for a significant amount of investment in energy efficiency in local communities throughout the region, and therefore energy savings on our utility bills. And it's not just the money that we save on the bill, but then what we do with that money that expands that impact when we take that money and re-spend it in our local economies. And this combined together helps increase the demand for energy services and products, which results in new or maintaining local jobs, because the vast majority of jobs created through energy efficiency are local jobs. And this is a chart created by the Southeast Energy Efficiency Alliance in a report they did in 2014. It shows what that economic output is per $1 million of investment in energy efficiency. So for every dollar that goes in, how many dollars of economic impact come out, and you can see that it's pretty significant. Throughout the Southeast, it's approximately a 4-to-1 ratio. And then in some states, as you see, it increases to as much as 5-to-1, such as in Tennessee. And so it's a huge driver of economic development and economic impact. And the same goes with jobs. In the United States, the average number of jobs created or sustained per $1 million is approximately 13 to 14 jobs. And you can see throughout the Southeast, and this is true for most of the nation, energy efficiency investments have a greater job impact than the average dollar spent in our economy. As many as 15 to 20 jobs on average in most states, and that includes direct, indirect, and induced jobs. And so just another illustration of what type of impact investments in energy efficiency can have. And when I was putting this presentation together, one of the thoughts that I had was that I could go through every single type of energy efficiency financing available to folks, particularly those who are listening. But I'm going to kind of glaze over and direct you to resources where you can find more about what is available to you through federal, state, and utility programs and other opportunities for supporting home energy efficiency improvements. But there are incentives and programs that are accessible for residential, commercial, industrial, nonprofit, local and state government, tribal entities, and electric utilities to support greater investments in energy efficiency and to support residents like ourselves to be able to pay for those improvements. These come in various types, as you see, grants, loans. There are home energy efficiency mortgage options available in certain areas, and performance incentives, tax credits. All of these are available out there, and I encourage everybody who's listening to take a good look at the Desire website. It's the database for state incentives for renewable energy, to see what's available to you through your state, your electric utility, or from the federal government. And there's a couple to point out. One, there is a residential energy efficiency tax credit that allows for a credit up to $500 for a wide variety of home energy efficiency improvements. Unfortunately, that is set to expire at the end of the year, so if you're able to make those investments, this is a good time to do that. And I apologize for the fire engine. And then there's other programs that are available through different federal agencies. One of the most popular and largest programs is the Rural Energy for America program. That's available for businesses, the commercial sector, local and state governments, and agricultural producers. And it provides loans and grants for renewables and energy efficiency up to 75% of the project cost. Only 25% of that can be from the grants, but they do provide loan guarantees for an additional 50% of that project cost. There's the Low-Income Home Energy Assistance Program. That is a federally funded program through the Department of Health and Human Services that it's predominantly used for helping folks who are unable to pay their bill, their heating or electric bill in the wintertime, or any time throughout the year, but it's more focused on the wintertime, to make sure that their electricity stays on, that their gas continues running, so that they don't freeze in the wintertime. One of the more popular ones, or the most well-known, is the Weatherization Assistance Program, which is administered through local entities that are typically known as community action agencies. That name could vary by state, but those agencies cover a small subset of counties, but there's enough agencies throughout each state, or should be, to provide free weatherization assistance grants for eligible low-income properties, and it covers the full cost. Unfortunately, the downside is that there is a limited amount of federal funding for those programs, and the agencies that administer them are typically have a small amount of capacity and are underfunded, and so you see long waiting lists across the board for those services. But if you are a low-income resident and you believe that you need help improving the efficiency of your home to help reduce your energy bills, please do look at who your local implementing agency is, and get an application in, because the sooner the better with those. And then what I'm going to focus most on are electric utility programs. A lot of electric utilities offer some sort of financial support for home energy efficiency improvements, or even business energy efficiency improvements. Rebates are the most common form. Large utilities, investor-owned utilities such as Duke Energy and the Tennessee Valley Authority and others, typically offer rebates for heating and air new heating and air systems, appliances such as new refrigerators or water heaters, building envelope improvements, as Marcus talked about, lighting, etc. And the website that I mentioned before has a list of by utility of what rebates might be available to you. But the sort of a product that is growing in application pretty rapidly, particularly these days, are loan or tariff-based products for financing comprehensive home energy efficiency improvements. And you can see these both as on or off bill programs. On bill means that you repay it on the bill, or off bill where you're paying the financial agent institution directly, and the utility helps you go through that program and processes the application. And the loan-based products are generally, they require credit score limits to ensure to determine eligibility, but they are a debt instrument. So if you move out of your home, then you have to pay off the remaining principal on that loan, and they aren't tied to performance. So they don't guarantee any types of energy savings or target any energy savings associated with those improvements. But there are a lot of electric utilities that are offering those loan-based products now, and we can help you with a list or to navigate the Desire website to see if your utility does offer something in that form. What we're promoting are tariff-based on-bill financing programs, and this is a growing source of utility financing, particularly for small utilities that serve rural populations. And I'm going to talk about that. So these are called on-bill financing programs, tariff-based on-bill financing programs. Tariff is just a fee on your electric bill. And so generally, on-bill financing is a financial support for offering or being able to pay for comprehensive energy efficiency improvements. They're typically low interest capital when you compare it to what your local bank may offer you. And then once those improvements are made, the resident repays the utility through a new charge on the electric bill using a portion of the savings. And that portion of the savings, part of the definition, is related to tariff-based on-bill financing programs. And the intent of those programs is for the annual savings to exceed those payments that you're making on your monthly bill in order to repay your utility. There's a specific model that we prefer. It's called pay as you save. It removes the upfront cost barrier because the utility is paying for the full upfront cost of the improvements. They look at your bill payment history and not your credit scores in order to determine whether you are eligible. And that means that if you are generally in good standing with paying your electric bill, then you'll be eligible for those programs. You do repay it on the electric bill through an extra charge, but the goal of those programs is to, as I mentioned, make sure that you are actually saving on average over the course of a year, even though you're paying a new charge to the utility on your bill. And the repayment is tied to the electric meter, which means if you move out, you are not liable for obligated to repay the utility the remaining principal. The next person to purchase the home or move into that rental property continues paying off that charge. And this allows it to open these types of programs to be open to renters and multifamily properties, which is something that your typical loan-based products don't offer. The result of these improvements, as Marcus mentioned, is that you can reduce your total energy consumption by 20 to 40% and save 5 to 10% on your electric bill because you are paying off a new charge. And as I mentioned, the programs like this are growing. The longest standing one is the HouseMark Kansas program. There's also a program in Eastern Kentucky, a lot of new programs in Arkansas, one new program in North Carolina, and a program in South Carolina that had 5 rural electric cooperatives participating called the Help My House program. And in the interest of time, I'm going to kind of glaze over a couple of slides. But this is basically how the programs operate. The utility pays for the investments. Local contractors do the work. Once their work is approved, the utility pays them for the work. And then the utility starts you start paying off that investment back to the utility on your electric bill. So that's kind of how it works. And these programs have been highly successful, saving customers an average of 20 to up to 35% on total energy use. and investing over $7,000 per home. So, and then there's another program model, and I only have about 1 minute, so I'll glaze over this, but it's called Property Assessed Clean Energy Financing, and there's a lot of details that go into this, but if you're interested, reach out to me or do some research online to see if your state has authorized PACE programs. But there's another on-bill type of financing for energy efficiency, renewable energy, and water conservation, where you repay that investment on your property tax bill. And if you move out, that repayment obligation again stays with the property, and you don't carry that debt with you. So that's another exciting model out there. And that's a growing model. When I last did this type of slide, there were just over 30,000 projects financed. That was approximately 8 months ago. And just in those 8 months, there's been another it was about 24,000 new projects reported on the residential side. So these are leveraging, pardon me, calendar. These are leveraging millions of dollars in investment, over 1.2 billion invested in the residential side alone. I apologize, I should have turned my calendar off. So I'll stop there. There are a number of resources. As I mentioned, the database of state incentives for renewable energy is a great resource to go find out what is available to you in your state through your utility, through your local government or otherwise. And then the property, if you want to learn more about property assessed clean energy finance, pacenation.us they have a lot of information and they have a state-by-state breakdown of what the status of PACE programs or legislation is in each state. So I will stop for questions.
Wonderful. Thanks so much, Rory. That was a lot of information. It was a great presentation. For those of you who need to leave right at 3, thank you so much for joining this webinar on energy efficiency. And for anyone who can stay on for just a few minutes, we do have questions for each of the speakers. So Marcus and Jennifer, if you could turn your videos back on. But Rory, I'll start with you. The first question is the energy efficiency tax credit available at both the federal and state level, and is it refundable?
Is it refundable, the tax credit? We might need a clarifying statement on that, if you would.
Yeah, Amber, if you want to send me a clarifying statement, I will submit it to Rory or get you an answer after the webinar. Marcus.
I think I might do it. I apologize. I might be able to provide a quick response to that, or what I assume might be a response. But what you would do is claim that credit on your tax forms, and that would, I believe, the way that would work is it would reduce your taxable income, or it would reduce the amount of taxes that you would have to pay in that year.
Okay, hang on 1 second. I'm just changing the screen here.
Okay.
Now,
to that, I'll add that is what I mentioned was a federal tax credit, but a lot of states do offer tax credits on the state level, and you would just have to go to that Desire website to find out what's available in your state.
Okay. Marcus, for you, there was a question from a member of the audience who, it sounds like he wants to switch to LED lights, and he wanted to get information about where the best places are to buy LED bulbs and whether there's any special things to consider. Do they take the same sockets or any other information that the buyer should be aware of?
Right now, the big box stores are probably the least expensive place to get them, and at least in our area here in North Carolina, Duke has actually given an incentive that is a pre-consumer incentive. So, for instance, to do some of the insulation and air sealing, you basically get some cash back from the utility after the fact. Well, with the lighting, they've given that to the stores, the big boxes, and so the LED prices are the lowest they've been ever. So I'd recommend a big box store like a Lowe's or a Home Depot. Check those out. Most of them are the standard Edison base or Edison socket that we're all familiar with. Keep in mind, because I've made a mistake before, I found ones on sale and gotten excited and grabbed them off the shelf, and it turns out they were on sale because they were a different type of base. So just verify that in the store. And then another problem that has been attributed to LEDs, just like the compact fluorescents, unlike the incandescents, which are basically just one light, one type of light, one intensity, and one spectrum. The LEDs and complex, for instance, do offer different types. So a lot of the big box stores will have a display that kind of lets you look at the different lumen qualities, different light intensities, and different light spectrums. I've definitely bought a daylight spectrum, which was just like daylight, and it was far too bright for the place that I wanted it. So just spend some time in the aisle reading what they're trying to tell you on the boxes. I also recommend, if you're replacing all your light bulbs, which is great, buy one of each type and take it to your home and see which one works best in, some are better in lamps than overheads and the like. And so feel it out before you make a big purchase, because we have seen that where people have done a replacement and then not been happy with it, and then they just go right back to incandescence instead of realizing that there's just a lot more options with the LEDs.
Great. Great question.
I just want to chime in there. If I can just chime in there very quickly, yes, definitely check your pricing. And I've been able to purchase them in a box of 6 for around $10 to $12, which is a very cost-effective measure for looking for LED lighting. So just to throw that in there, I found it at one of the larger box stores.
Great. Yeah, and staying with you, Jennifer, and LED lights, we had a question after your presentation if there's any recycling concerns with LED lights.
Not with the LEDs. There definitely are concerns when it comes to the CFLs. You do want to be sure that you dispose of CFL lighting correctly, because there is within that lighting technology, and that's true of any fluorescent lighting, there's a small amount of mercury. It's the type of mercury that you get from eating a can of tuna fish rather than the kind that you might get from, that we had seen before with the older thermometer styles. But nevertheless, it is mercury. It's not something we want to wind up in landfills. So the best way to dispose of CFL lighting is to take it back to the location where it was purchased, particularly within the larger box stores. They do recycle elements of it, so it becomes a more environmentally friendly choice.
Great. Thanks. Coming back to you, Rory, we've got a couple of questions. Can people in on-bill financing programs still get an energy efficiency tax credit for either the amount of their loan or the tariff they paid throughout the year?
Typically not. I think it depends on the type of on-bill program. If the financing is coming from a local credit union or a local bank, and there's a number of programs that do that, I'm not a tax expert, but I would anticipate that would be eligible for the tax credits because it is more traditional in terms of a type of financing for folks. As for the on-bill tariff, I anticipate that that's probably not going to be the case because the utility is the one making the investment, and most of these programs are offered through rural electric utilities that are generally nonprofit utilities. So so they're using either member capital or federal loan guarantees, and so I wouldn't think that the tax credit's available to customers there.
Great. And because of time, we do have a couple more questions, but because of time, we should probably go ahead and end this. And those questions that did not get addressed, I'll be sure to relay them to the speakers and make sure that everyone receives an answer to the question. So thank you, Rory and Jennifer and Marcus, and thanks to all of you who are participating in the webinar. This webinar was based on an article written in the December-January issue of our bi-monthly newspaper, The Appalachian Voice. You can read that article or subscribe to the paper online. And be sure to join us in early March when we'll have our second webinar in the series, which will focus on issues of land ownership and mineral rights in Appalachia. Details about this will be on our website soon. In a moment, you'll be receiving a survey about the webinar. This survey is a requirement of my AmeriCorps position here, and I really appreciate any feedback you have to offer. There are just 4 short questions and then the opportunity for you to provide any additional feedback that you like. These questions will appear as soon as the webinar ends. And I want to thank you all again so much for attending and participating. Take care, stay warm, and goodbye.